The advanced statistic question says, a researcher believes that treating seeds with certain additives before planting can enhance the growth of plants. An experiment to investigate this is conducted in a greenhouse. From a large number of Roma tomato seeds, 24 seeds are randomly chosen and 2 are assigned to each of 12 containers. One of the 2 seeds is randomly selected and treated with the additive. The other seed serves as a control. Both seeds are then planted in the same container. The growth in centimeters of each of the 24 plants is measured after 30 days. These data were used to generate the partial computer output shown below. Graphical displays indicate that the assumption of normality is not unreasonable. Determine if there is significant difference in growth between the tomatoes with additives and the tomatoes without. Our table gives us our mean, standard deviations, and n. So for this problem, we're going to use phantoms. The P stands for parameter, and in this problem, it is growth of Roma tomato plants with an additive versus no additive. Our hypothesis for this problem is the null hypothesis, or the HO, is the mean of the control equals the mean of the treatment. Our alternative hypothesis is the mean of the control does not equal the mean of the treatment. So this means mean control. And this means mean treatment. The A stands for our assumptions. We assume it's a simple random sample. And even in the problem, it says a seed was randomly chosen. We also assume that it is normal, but n is less than 30. N is only 12, so we do proceed with caution. At the end of the problem, it does say graphical displays indicate that the assumption of normality is not unreasonable. So we're going to go ahead and write n is less than 30, so we proceed with caution according to the central limit theorem. N is our name the test. It's 2 samples, a control and treatment. It's in a t-test because we have a sample. T is where we actually do the test. Our equation is x bar 1 minus x bar 2 over the square root of standard deviation 1 squared over n1 plus standard deviation of 2 squared over n2. We're going to plug in our values. We have 15.989 minus 18.004, which came from the table they gave us, over 1.098 squared over 12 plus 1.175 squared over 12, all under a square root. We got all those values from our table, and we get that t equals negative 4.34. From this, and using our calculator, we can obtain an exact p-value of p equals 0.00026. If we have an alpha value of 0.05, our p-value is way less than our alpha value, and therefore we fail to reject the HO that the mean control and the mean treatment are equal. There is not a significant difference in growth between tomatoes with additives and the tomatoes without.